Hey, yo, chemsters, this is Mrs. Vandeloy bringing you the Chapter 7 Alcohol Nomenclature Worksheet answers. All right, so what did I do first? Excuse me. I redrew the structure from this form to this because this is a whole lot more visual. You can really see what's going on. Again, keep very close tabs on how many bonds each carbon has, and that may help you know where to put the O. The O goes on this third carbon right here. So how do I name this? All right. Well, I need to identify both where the double bond is and where the alcohol is. The alcohol is going to take priority, but it's on the third carbon, so it made no difference if I go left to right or right to left. So my plan B then is to place the double bond at the highest carbon, all right? So I put it on the ones, becomes 1-pentene dash 3 all. So when you have a case where you have like the ending matters, so like ane versus ene versus ine, if you have an ene or an ine, you need to let me know where that double bond or triple bond is, and then put the 3 all like that, okay? Let's look at letter B. Okay, so once again, I made the structure so it looks, this is kind of harder to figure out, so I redrew it like this. And once again, the OH is on the third carbon, so it makes no difference based on the alcohol where the lowest number is. So I'll just do it this way. So it's 2-chloro, 3-pentanol. Okay, what about the next one? This was kind of a fun one. Very similar to some of the other ones here. So I have, again, 5 carbons. So I have, this one has 2 carbons. This carbon right here is this carbon here. So it has 2 methyl groups hanging off of it. Here's the next carbon with the OH and then carbon-carbon. And so again, the alcohol's on the third carbon. So I just have 2-methyl 3-pentanol. Okay, what about the next one? Oh, they changed it on me. Now it's on and more closer to the end. It's not in the middle one. So this time it does make a difference where you place the alcohol. So the alcohol takes the priority and it is going to be on the second carbon. So I'm going to number right to left and becomes 4-chloro-2-pentanol. The next one, again, same idea, where I'm going to number it from right to left so that the alcohol is on the second carbon, so it becomes 3-methyl-2-butanol. And then the last one here, all right, again, there's a lot of stuff going on, but really the longest chain is still going to be a butane. So I'm going to number it from right to left again. So I end up with 3-bromo, because bromo comes before M alphabetically. So 3-bromo, 2-methyl, 2-butanol. All right, so now we got to name the following down here. Okay, so I just went ahead and numbered the first carbon where the OH is. Why did I do that? Because it takes the priority, doesn't it? So if I number this 1, therefore the chlorine's on the 2, 4, 6. So I have 2,4,6 trichloro cyclohexanol. Why didn't I put a 1 in this? Because the alcohol takes the priority. So if there's only one alcohol, then it has to be on carbon number 1. Did you hear that? So if you have a cyclo, the alcohol has to be on the number 1 carbon, and then the chlorines have to be numbered. So I didn't have to put it there. So this one is just plain old cyclopropanol. I don't need, again, put a 1 on it because it's inferred it will be on the 1. And here, again, the OH is on the first carbon, putting the methyl group on the 2. So it's 2-methyl-cyclobutanol. Let's go to the next page. All right, so this kind of goes back, and you have to remember the big 9. And I had told you that alcohols take a higher priority to most functional groups, but not 3 of them. They do not take priority over aldehydes, ketones, and carboxylic acids. So you have to recognize very closely what is this structure right here. Which big 9 is this? And that's benzaldehyde, which is one of those that the alcohol group takes second seat to. So how would I name this structure? Well, if this is my first carbon, then the oxygen is on the third. So I have, the OH3 hydroxybenzaldehyde, or you can always use the ortho meta pair. Yeah, I had to make sure that for a second. I had doubts. So anyway, or it's meta hydroxy benzaldehyde. Okay, what about the next one? Okay, here's my big 9 functional group. All right, and what do you recognize that as? That's a phenol. Now, is this going to take higher priority? That would be, if I were just going to look at this functional group, that'd be ethylbenzene. Does ethylbenzene take priority over phenol? No, it does not. So the phenol takes the priority. So I have 2-ethylphenol or ortho ethyl phenol. Okay, either one works. And then finally, over here in letter C, I don't know if you recognize this, but that's a benzaldehyde. The question is, does benzaldehyde take priority over a phenol? Yes, it does. It's one of the 3 that is higher priority than an alcohol group. So remember, it was an aldehyde ketone and a carboxylic acid. So yes, this does. So then I have to number it. So I get 2,4-dihydroxybenzoic acid. Okay. All right, so now we get to draw. All right, so first I drew a 1-butanol, and I put the OH on this carbon. If you wanted to, you could always put it on that carbon. I don't care. All right, so if this is my first carbon, this is my second carbon, I have 2 methyl groups hanging off of it. Now I have a phenol. All right, there's my phenol. All right, and then in the M group, the ortho meta, this is my meta, I have a bromo group. Okay. What about the next one? I have a cyclopentanol coming up, and 1 methyl off of that. So there it is. My methyl and my alcohol are on the same carbon. Okay. The next one is a cis 2-methyl cyclopentanol. All right. So I tried to show you they're both going in the same up direction. So it's cis, same side. So 2-methyl cyclopentanol. All right. Letter E comes back to your R and your S. And so here I have S. So remember I have A, B, C. All right, so here's my ABC going around in the counterclockwise sinister motion. So I made it into the S2-butanol. Letter F, notice I have both a double bond and an alcohol on this. So for whatever reason, I made this my first carbon. All right. So here I have my 2-methyl and then my 2-propene. So my double bonds also off of this one, 1-all. All right, almost done. So now I have 2-cyclohexenol. All right. I'll just be straight up honest with you. I had kind of a brain freeze when I went through and did this one because here's my hexene. Cyclohexene is right here. So if I made this carbon number 1, carbon number 2, this becomes carbon number 3. But if I put the OH group here, then it becomes on carbon number 1. So I'm like, is this really right? I actually looked it up on Google. Of course, it has every right answer. And this is the structure that they did come up with. If I were numbering this, I would make that 3-cyclohexenol. But we'll just go with that, all right? Trust me, I won't ever ask you that on a quiz or a test if I'm having some confusion over why that's correct, okay? So again, I was torn with that one. I hope you understand why. I don't quite see why that one works unless I'm just not getting it. All right, the last one is, I'm looking over here, it's the acetophenone, all right? And notice it's a ketone. So here is the big 9, all right, and it's a ketone. If you remember, alcohols take a backseat to aldehyde, ketones, and carboxylic acid. So this is the ketone that they take a backseat to. So I had 2,4-dihydroxyacetophenone. Okay, I sure hope this helps, and don't wait to be great. We'll see you next time. Bye.